As you can see, 0.67 volts. From what, you might wonder? Well, this is my radiant energy receiver, which is mounted on the fence. And as you can see, we go down here. Got about 100 foot of coax. That's all I'm using is coax. And here goes the ground to this pipe here, which I think used to be one of those clothes spinning things. And at the top of there we've got what used to be an old wind turbine. But the ground, I'm not sure how far that pipe goes in. But there's the full look of it. Let's say about 100 feet of coax, and I've noticed if I add simply to the end of these top ones, I end up with 0.1 volts extra per 10 feet. I've got no termination at the moment, just ends in the wire there. And at the moment we're using a 1 UF capacitor with 4 small diodes, just as a full wave bridge rectifier. And there we are, 0.67 there. Now I'll show later on running an oscillator, which this can do. It can run a penny oscillator, and I'll be using this one here, which is a 250 volt 220 UF. So here we have the oscillator running. You might be able to see the flashing. I'll show it later on when it goes dark. But it runs like that all the time, so there's enough coming through to power that oscillator. That's the halfpenny oscillator. And it makes a good little beacon to find your way as well. The nearest power line is, well, that one I think there. It's about 30 feet away, at least. And about 20 feet from the nearest outlet in the house as well. So I'm very happy indeed with this. What I have noticed is that if I disconnect everything, the meter or the oscillator or whichever, and let this just charge up, I got to 8.2 volts yesterday morning. So it looks like that's the way to collect up power. Right, later on I'll show this flashing at night. Well, I found a bit more coax to add, so that'll be going on later on. But what I've done, I've put this capacitor on for a couple of hours now with the meter off. I'll spin it round to show the voltage. It'll drop down quickly because it's got the load of the meter. Oh, 9.5. So it looks like overnight probably get past 10 volts. That's excellent. Actually, it's too much to run the oscillator later. So I think I've got to I'll blat it round and get rid of all that now. There we go. Whoops, 120 milliamps. There we are, and now it will start to climb again. And you can see the charge rate anyway for a, what is it, 220 UF capacitor. That's climbing quite well. So what I'll do is I'll put the oscillator on, and then I'll show this running at night. Just to note, with that wire on, I've gone over the 0.7, it's 0.709 there. And here's that wire that I just showed before, just attached. You know, those birds would make great cell phone ringtones, wouldn't they? Change about every 4. Anyway, there we are, 0.713. And that's with the 1 UF, so you get more of a real-time reading. here we are with it flashing at night. Now I'm thinking for nature trails and forests and what have you. And if the light's on the left, then you're going towards a campground or somewhere. If it's on the right, then you're going away. But this has been flashing away since 4 PM. It's now 9 o'clock. It runs all the time. Okay, thanks for watching.